Okay, so it looks like we got a good group. So I'm going to go ahead and get started. And we've got some time together here until for about the next hour. So I want to talk about sort of a fun topic for us, Be My API. We talk a lot about creating APIs, designing them, implementing them. So we wanted to cover sort of a general topic here. So hopefully this will give you some ideas on a couple of different things. So we'll get some preliminaries out of the way. I have a lot of material I want to try to cover. So we'll get as much as we can. So you probably know my name, Mike Amundsen. You probably recognize this avatar. I go by lots of handles. The one I'm most proud of right now is Principal API Architect for Layer 7, a fantastic group to work with. Sometimes called the Hypermedia Junkie. I wrote a book called Hypermedia APIs with HTML5 and Node. It came out in 2011. And I'm really proud to say that I'm now working on a book called RESTful Web APIs with Leonard Richardson. Leonard and another author wrote probably one of the first really big books on REST in 2007, and the two of us get to team up for a new one. I also want to take a minute to remind everyone that the API Academy team at Layer 7 has actually got some really, really great talented folks. Ronnie Mitra is based in London. Ronnie's a very, very strong architect, got lots of enterprise and security skills, travels around the world doing the same kind of work I do. We've also got Alex Gaber on the team too. Alex is his official title is API Evangelist, but he's a fantastic mobile developer, great on community development and building. So these are great resources, and a lot of the material you'll hear me talk about today actually comes from their work as well. This isn't just my stuff. It's a lot of things. I also want to just take a moment to say we're really proud. Just this week, a new Forrester Wave came out for those who read these kinds of things, and it rates us really, really high in this API management space. And that's a reflection not just of the technical details, but also of the guidance of people like Ronnie and Alex. So we're really proud to be part of that. You can actually download a version of this at the link at the bottom of the page. And these slides will be available as well, so don't worry about writing too much of this down. The Academy actually has a video series. We have a bunch of 5-minute sort of like snapshot videos on various topics. Again, a lot of material you'll see today comes from those videos. We keep adding more. We've got about 6 right now, but we add a couple every month. We just started this at the end of the year. So it's a great place. You can kind of replay that 5-minute video anytime you want. It's a nice series. We're also getting I'm not quite sure how to get a link there. We're getting a website up. That's going to be the API Academy website. It's not quite ready yet, but it's also going to then host all the videos, be a place for white papers and content, and a lot of other cool stuff. Okay, so just a little bit more housekeeping. As we're going through this, post questions in the Q&A. I'll take a little break at the end of every section, and we'll also try to save time at the end. But as soon as you come up with something, post in the Q&A, and then we'll cover those towards the end. If you want to talk about it on Twitter, L7 Webinars are tagged. You can follow me. You can follow Layer 7. You'll also be able to find Ronnie and Alex and several other people on Twitter as well. So I think that's the start of things. And now we can get started. So the idea was APIs that everyone can love. And when I think of everyone, we really think of a couple of different cases. We think of the people who are interested in the business of APIs, product managers, that type of person as well. Also architects, people who have to design and make these things work functionally. Everyone charged with implementing an API, supporting it, scaling it over time, making modifications and changing it. And then finally, the people who use the API, and that's mostly developers, but also how it affects users. So I want to touch on each one of these, the business side, the architectural side, the implementation side, and then what we call interaction modeling, treating the API as an interaction interface and being just as careful about it as you would with any user interface. Okay, so let's just talk a little bit about the business of APIs, because there is a business involved, right? So you need to think about consumers, who's consuming this API and why. Why are you creating an API? What do you want to acquire? It may be users, it may be content, it may be creating more reach or more loyalty with your existing users. And then what kind of product modeling do you want to do to make sure you get the right feedback and the right information as you move forward. So we think about it this way. If you're API consumer, the people you are targeting this API for are private. Maybe they're internal or contract developers. You might design an API differently. A good example is very often you have this implementation control where people cannot even put source code into the system or use the API unless you get to review it. So you've got a lot of control over this. And also your product is really well understood. Whether you contract with somebody, it's somebody within your organization or within another division, very often they already understand your object model, your business model, and those kinds of things. You might change the way the API looks for that group. You actually control what they do, and this is a sort of a classic sort of enterprise style, but it works the same in startups as well, sort of approach to things. Your agenda is aligned with the people who are creating something for the API. Hey, we need to build a mobile app. Let's build an API, and the guys down the hall can build the app. So that's a pretty standard pattern. Your APIs really give you the ability to strengthen what you already have, strengthen your products, strengthen your place in the marketplace. This is a way to continue your agenda maybe on a new platform or in a new direction. That might be slightly different than if you're dealing with a partner and you want to really get partners that love your API and love what you do. So we call these strategic partners. There are lots of different ways you can think about them. You have a limited implementation control over them. You can't really tell them what source code to use or what languages to use or whether they should be agile or whether they should be using functional programming or whatever. But you do have some agreement with them. And very often what you'll do is you'll produce an SDK, a software development kit. This gives you a sense of control. You can give them a view into your world. Your API becomes that SDK in some cases. So now you know what it is, and you can also coordinate with them. When you release your SDK, they update all their code, and you have this coordinated ability to work with them. So your control is their access to your internal content or your internal APIs, and their access to that SDK itself. You do have a pretty good sense of control over that. And your agenda is very often cooperation. Maybe they're in a market you're not in, or they're doing things that you'd like to be doing, but they're better at it. There's a great, symbiosis here. So they're not necessarily the same business as you, but they're helping you quite a bit. So partners often let you extend your market or create new directions in the same space or join up with others. So a partner relationship when you design the APA could be a very different way of designing it. And then to pick sort of another end of that scale, that's what we call the public or third-party developers. These would be people that you really hardly even know or that you wouldn't even see. You have little or no implementation control. You can't tell them what to use or what platform to run on or any of these kinds of things. Your real primary control is the API itself. What the API looks like, your access control services, your monitoring, your traffic management, your SLAs. This is how you communicate with that community. And how you make that API look could be very, very different than if you're releasing SDKs or working with internal teams who know your object model. So your control is the API itself, and that's really the face that these people see for you. And very often, your agendas don't match, or they could be wide open. They might even be mashing you up with competitors' material to give consumers a kind of a leveling effect, like here's all the various shopping sites, here's all the various things you could do with it. So it's a pretty wide open deal. The cool thing about public APIs is very often they give you a chance to learn brand new markets you hadn't even seen. And from a product manager's perspective, or from a business manager's perspective, this is a fantastic gift. There's a risk. The risk is that these third-party developers will do things with your API you hadn't planned. The benefit, the value back, is that you may discover brand new things that you hadn't even thought of before. So that's actually pretty important. So just thinking about those in terms, in general terms, helps quite a bit in thinking about your consumers. Strengthening your market, extending it, or discovering new markets, and you may take different approaches. Very often you don't do just one or the other. You'll mix and match, but it helps to think of the controls, the risks, the benefits in this way. Let's talk just a little bit more about reach. Like, why are we doing this? Do we want to increase our base? Are we trying to enter new markets we haven't been before? Are we trying to just create awareness and presence in the space? There are lots of things that I might be doing. So maybe what I want to do is I want to leverage existing products by creating a new app that acquires more users or something like that. But there's another possibility, and that possibility is I actually want to acquire content. I want to get information from the user community. So I want to increase contributed content. I want people to comment on product. I want people to actually upload pictures of them using my product. I want people to socialize and tell me about where they are when they're using that product. I want to gather this behavioral data. This is a huge, huge area, especially in the mobile space, because we have so much additional information that mobile devices give us, and users seem very happy to provide. Where I was, when I was using it, what I was doing, and here's a picture of me and the friends, and here's a comment to send to everybody. So one of these things is you might want to acquire new connections. You might want to be able to find relationships with people and then start to market them in a new and different kind of way. So building on the existing infrastructure that you have, the product that you have, the information system you have, and build on that to create new information about how you might create new physical products or new services for someone. And then there's the idea of just simply acquiring users themselves. I want to expand the user base. If I can put this on a certain device in a certain community, then I can get more eyeballs. I can increase traffic. I can actually increase not just my reach, but also my depth. I get actually more responses from users now. I used to get 1 a month, now I get 20, now I get 30. So there's a lot of other possibilities. I may want to increase the amount of user data I get from folks, how often they do things, encourage them. I might create psychic rewards, like you've commented 5 times this month. If you comment 5 times more, you get a free prize or something. There's all sorts of things you can do to learn more about your users and create another relationship. Deepening customer relationships may be one of the best reasons to create these interfaces that we can build applications upon. So when we think about that, leveraging products, building on existing infrastructure in existing base, and deepening the relationships that you have, these are all things that are good reasons to create an API. Notice I didn't actually put on this list selling more units. I mean, you could use that as well, but what I'm trying to do is also get you to think about other reasons that creating application interfaces may be an advantage to your organization. So we have these ideas about how we might want to increase reach or depth, but how do we know that? How do we know our product? And remember, think about your API right now as a product. So how do I know what's being used? I have lots of interfaces. I have lots of calls. Which one of those are used? Which one of those cause errors? Which one of those bring in the most traffic? Which one of those are the most problematic? And who is it that's using them? So what developers are using them? What apps have they built with them? And how do those applications and developers affect my bottom line, affect my goals, my acquisition goals? And when are they using them? Is it certain times of the day? Is it around events? Do we have shock loading at holiday times? There are lots of other things that I can learn about my product if I monitor properly. And what we say is you are the best source of big data. You yourself are the best source of big data. There's tons and tons of information that you can use to improve your relationship with your customer and to improve the value of your end product. So what you need to do is you need to measure. So you need to figure out what are your metrics. If your metrics are user-based, then it's pretty easy. I have more users than last month. Maybe it's not just increasing the user base, but maintaining it. You want to end churn. My average length of time for a user is now 6 months, or whatever the case may be. Figure out what those metrics are. I can tell you from a developer standpoint, what developers are going to be most interested in are latency, uptime, and reliability. They really don't care about units or numbers, but what they care about is that the system is very responsive, that it doesn't go down, and that the responses, the answers, the values, the computations are very reliable over and over again. I don't get mixed messages or confusing information because developers want their apps to look good. We want developers to love us as well, right? So There's also the issue of performance, how many installs I have, how much traffic you're getting, how stable your system is. These are things that when you want to measure developers, like do those developers generate a lot of traffic for you? Is there one developer that generates most of your traffic, or one team, or one group? Are their applications stable, or are their applications pretty shaky? And is that reflecting badly on your API product and your end product as well? So you also want to be able to monitor not just the performance of the API, but the performance of the developers using the API. So that's very important. You can't improve what you don't measure. So you need tools to make sure that you track this information and report this information as well. And the biggest reason you're going to do this is because this gives you a chance to make changes, to modify things. Small changes can mean big results. If I just modify this one API, it's going to increase performance, or it's going to increase use, or it's going to increase staying power. Use your APIs to test new ideas. We tell people to think of APIs as just that, the interface, the thin layer on top. You can get a lot of feedback by just testing out new APIs themselves with developers. And you can do that through hackathons, code events, all sorts of things. Now, a lot of time we hear about continuous integration in software development, CI. One of the ways we talk about it is constant improvement. Every tiny little bit helps. Create an environment where it's easy for you to make minor changes without hurting things and improve things, to get feedback and turn that right around into something else. What we talk about is turn feedback into features. As soon as you get feedback from developers, then make that happen. Sometimes that's easier to do in software than it is in a primary product. You may have a physical product, whether it's a utility, a device, any kind of industrial product, and that may take time to put new features into a new production run, a new factory run. But in software, sometimes we can do it much quicker. So your data is really important, and you should treat it as gold. You can't improve what you don't measure, and you can turn that feedback into new valuable features. So that just sort of gives you a sense. When I think of product developers, managers of the business, we think of these kinds of things. Who are our real consumers? How can I target that audience and reward them? How can I make sure that I'm actually doing what I need to, increasing my reach, my users, my content? And how can I make sure that what I'm modeling, I monitor, measure, and modify so that I can improve all along the way? And those are the things to think about on that product side. So let me just take a second here and take a look. Okay, so I do actually have a question here from Rich. In the case of a public API, are there use cases or other guidance that you can point to keep information security and legal from having a cow? Oh, okay, so that, I think I understand. Let's see, and help them not freak out by, oh, well, it's a little late for that, isn't it? Actually. So let me just say this. There are cases when you create public APIs that you need to consider what you're exposing to individuals. And that's why we tell folks when they create APIs to design APIs that are not based on your private information, but based on a public interface. You can create an interface that has nothing to do with the way your business operates. It's simply an interface to get at things. You may have cases where people are worried about the way your content is going to be used. If content is your product, then you have additional risk when you create ways for other people to use your product. And this is a choice that you have to make. Sometimes, if content is your product, you want to create applications that allow people to tell you how they use the product without actually using it in the same app, if that makes sense. In other words, you can create lots of different applications. This goes back to the idea about reach and content and users. You may want to create applications that create the depth of use, not necessarily increase the actual shared use. So there's a couple of different possibilities there. I'm not sure if that makes sense, but yeah, you're definitely going to have legal issues, but I wouldn't get too worried about that because you have lots of other things that you could do besides just having people use your content directly. All right, let's go on. The next section I want to talk about is aimed mostly at the architect space. And this has to do with creating properties or abilities in a system so that your architects can love your API strategy as well. A lot of times when somebody comes up with a great idea for APIs, they don't really think about how this is going to affect the overall architecture of the system. So these are sometimes referred to as abilities or non-functional aspects of the system. We're going to focus on three of them that we talk about a lot: usability, scalability, and evolvability. So this is a picture of from Donald Norman's work. Donald Norman wrote a book called The Design of Everyday Things, a fantastic book, and it talks about how people interact with the world and how they use things. He really becomes the father of usability. Nielsen Norman Group is one of the premier consulting firms in this area. And this is an illustration from early in his book. He talks about how we interact with the world. We actually decide on a goal, have an intention to do something like I'm going to go turn on the lights or I'm going to adjust the heat, figure out what it takes to do that, find the switch or the dial or whatever, execute it, see how the world reacts, interpret it. Is this bright enough, or is this too hot in the room? Am I done? Do I need to tweak this a little bit more? And we go in this circle, in this cycle. So this is called the execution evaluation cycle. It's a very well known at this point, especially in user experience, because it talks about things like how do I know which button to push when I want to do something. But this also gives us some real clues about how we want to create APIs, because API developers do this exact thing with your API. I want to solve a problem. I want to solve a task. Let me see. What API do I need? So you're now in this sort of intention to act, sequence of actions. Now you execute it. Do I get results back? Can I actually see what happened? Do I execute it again? Is 200 okay enough? So this whole idea of making things usable is really, really important. So we say the I stands for interface. Remember, this is an interface into your system. You can design this execution evaluation model however you like. We'll talk about interaction models a little bit later. But how usable is your interface? How usable is that? Is it very complicated? Do you have lots of arguments? Is it safe? Is it scary? Do developers worry about using this? So it's really important to create interfaces that are usable, APIs that look friendly, that look like, hey, I know exactly what I need to do. It says right there, buy a code. There's a buy a code API. That's what I want. So what we tell people is to focus on users and tasks. Don't focus on objects. We'll talk more about this again on the interaction side. Use empirical measurement and use iterative design. This is why we say you can create new APIs and test them over and over again. So be prepared to measure and iterate to make your APIs usable. This will include documentation as well. When I look at the documentation, do I see 50 things to do? Does it look like this airline cockpit where I'm not really sure if I hit the wrong button I'm going to crash? Or does it lead me? Is it use discoverability and all these other things and progressive disclosure, all the things that we know from the user interface? We can do that as well. Scalability is also an important one. So scalability works on lots of different levels, but what's really important to keep in mind is designing scalability in first works best. If you find out that you're not very scalable and you say, I'm going to add some more memory or add some more disk, you're not going to get a big benefit out of that. It's better if you design early on, better if you design in the early stages. And that really means thinking about the difference between scaling out and scaling up. Scaling out means I can add more machines. Scaling up means I get a bigger machine. And you want to get to the point where you can scale out easily. If you start getting more traffic, you start getting more success, you want to add more machines to the system. And that's really important. So architecturally, planning from the very beginning to add more machines can take away some of that risk about, oh my gosh, what happens if people actually use this? Which actually comes up. We already talked about this. Scaling up is technically easier because you can do it at the end, but it's a lot more limiting. It's a lot more reliable to use scaling out. And this is why if you look in the architectural side, Fielding's the guy who invented REST, but he has this layered constraint in his architectural model for this very purpose. So you can arbitrarily scale out at any time by adding machines or removing machines. It also means you can increase uptime and reliability with this notion of being able to scale out. So a lot of this also takes advantage of this idea of DevOps practice, the idea of shortening the distance between the developer and the operation side or the deployment side. And that actually follows right in with Norman's execution evaluation model, shortening that circle, shortening that gap. So from what a developer does to when it gets deployed, gets smaller and smaller, and if we need to scale this out, we can scale that out as well, not just the code. So be prepared to scale out. Scalable is very, very important in any kind of interface. All right, and I want to talk about one more item in this section, and that is this notion of evolvability. Evolvability is sort of this magical thing, right? This idea that I should be able to evolve and change safely over time. But it's not as really as magical as you might think about it. This is the way we talk to people about it. The notion that there's one thing you can do, which is extend the system. By extending the system, as long as you don't remove anything that's already there, as long as you don't change the meaning of what used to operate, as long as everything you add is optional, you won't break anybody as you extend the system over time. And it's really important to think about this. What's going to happen is as you build a system that becomes really popular or really functional or really usable, people will start requesting new things. And you're going to fall into a trap of trying to change what you used to do into what you want now. And that's not really what you want to do. There's a great quote from Rich Hickey, who's developed Datomic, a very interesting data service. And he says, the past never changes. So don't try to go back and rewrite history, change what you did a year ago and make it look like this. Instead, add to what you have. And that's really, really important. Now, versioning is different than extending. Versioning creates a new thing. It's actually creating what we say a new timeline on the internet. Version 1 and version 2 are probably not going to be compatible. And just like any timeline in the universe, you have to be really careful about crossing the streams. If you're not careful, you're going to cross from one timeline into the next. You're going to break something, break data, who knows, maybe even kill your father, and what's going to happen to you, we don't know after that. So be very careful about creating all these multiple timelines that you have to maintain. Most component-based software that isn't on the internet, we're used to using versioning to kind of identify things because we coordinate releases on all those versions. When you get to the public internet space, especially when you get to third-party developers, you've lost that ability to coordinate. You can't really tell people when a new version is going to happen and expect them to all magically join up. Because what's going to happen is you're going to end up versioning and people are going to ignore you. Be prepared for clients to ignore these version details and possibly suffer the consequences, possibly give your product a bad name. I'll just mention one right now. Twitter is about to go through the process of end-of-lifing their version 1 API. They've been working on version 2 for more than a year. They're going to give everybody about another 6 months, and then they say they're going to start shutting it off. This will be a really interesting test to see how versioning on the public internet with uncoordinated clients and applications works. And I can tell you that unless you must, we tell you don't version unless it's unavoidable, and usually it is avoidable. All right, so yeah, the other line is don't create dodo apps. The idea is don't create apps that are sort of evolutionary end of line, right? You create something and then you abandon it, and you create something else and you abandon it. Think about us. We've got tonsils, we've got an appendix, we've got all sorts of things that are just sort of left over, and things seem to work just fine. You don't have to delete all that stuff. You just leave it there. So I think that's something to keep in mind as well. So let me see, that kind of wraps this part. Let me see if I've got some questions here. Yeah, make sure your API is your interface and that it's usable. Make sure that your system can scale, and design for systems that can be modified over time. So let me see here. When developing an API for a large organization with several teams, what tools or processes do you feel can help communicate what is available in an internal API? Well, there's a lot of possibilities there. I have to tell you, one of the things that I see happening more often is people treating these internal APIs like public APIs. In other words, not assuming an awful lot about an understanding of the object model inside the corporation or the architectural design features. Treat them as standalone items and document them accordingly. The easiest way to coordinate with several teams is through an interface. And if you make that interface itself as explicit and as, we would say self-documenting, but not necessarily, the documentation that goes with that is clear as possible, and make sure that that's a separate concern from any of the component structure, then what's going to happen is the only coordination you need to have is on the interface itself. These are the things you can call, these are the arguments to supply, these are the responses you get. And you don't necessarily have to coordinate all of the back-end parts. We'll talk about this in the very next section. So if this doesn't really answer the question well, hit me up again, and I'll mention it as well. Here's another one. How do you reconcile these principles with Agile process where you minimize thinking forward? Well, I can't really speak to the Agile process itself as to whether or not it minimizes forward thinking. But again, if you focus on just the interface itself and write to the interface, then and make sure that that interface doesn't break over time, it really doesn't matter what processes you use that I know of. I know organizations that are very Agile focused. I know organizations that are very waterfall focused. And they're able to create very, very evolvable APIs for the public space by adopting just some basic principles about how you treat the interface itself. So I don't think you have to abandon this notion due to a particular format on the way you organize your teams or organize your code. So I think it's going to work fine there. All right, I think we're doing pretty good. I want to talk now from an implementation side, and I think this will actually touch on some of the questions we've had already. So this notion of what my product is and my strategy is, this notion about some principles about the way I'd like the system to work, how does that translate into some real implementation details? So here's a big important point. Components are not connectors. Talking from the implementation standpoint, when you're speaking on the public web space, there's a big separation of concerns between your components that are your internal items and your connectors, which are your public items. So components are all the things that you can recognize today: file systems, message queues, data storage, transaction managers, even the source code itself. These are your components. These are your unique ways of doing things. These are your value adds. No one else uses these tools the way you do. You may use one database format, one file system, one queuing service. There are lots of them out there. But it's not important that anybody in the public sphere knows this, because this is your IP. This is your intellectual property. These components are private. And because they're private, you don't want them exposed. This is a presentation about the internet, so I've got to have some cat pictures in here. So you want to hide all of those private parts of the system. That's very, very important. So with that in mind, what are connectors? Well, connectors are also things you recognize. The web server is the connector, a browser agent, like a user agent, a browser, any proxy service, firewall proxies, these are connectors to the outside world. Any shared caches, whether it's a simple cache at your machine, a cache at your firewall, a shared cache like Akamai or one of these other ones. These are all connectors, and you can tell that because these connectors all speak the exact same language, and they use the exact same standards to talk to one another. Web servers, user agents, proxies, and caches, there's no special IP inside any one of those. None of your intellectual property exists there. That's just to connect you to other things, connect you to the public world. And it's important to design actually implement your design in a way that keeps this in mind. So the connectors are just the tubes between various places, from this point to that point. So what happens is you implement your solution to convert component information into something that connectors can use. And that's really critical. That's where the interface happens. So this is how I think about it when I'm working on implementation. We got the web, that should say the cloud today, right? Because now we use the word cloud, right? And I have these clients and servers, these various implementations. And I could have lots of them. I'm going to keep it simple by making it look like it's a one-to-one relationship. And each item has their own set of components. If I'm on a browser knows how to store cookies. It knows where things are in the file system, all these other things. If I have a custom client that maybe, is a refrigerator that is internet connected, it knows about its own bits and pieces. Servers know where the data is stored, what the file system is like, all those other things as well. But they also have these connector devices. So my browser can talk HTTP, and my server can talk XMPP, and FTP, and DNS, and all these other things. This is the world we work in. And the really valuable work is done at the component level. And then the sort of mundane work, the heavy lifting, the day-to-day operational stuff is done at the connector level. Most of us purchase all our connectors. We don't build our own DNS servers. We don't build our own routers. We don't build our own firewalls. We buy them because that's commodity material. What we work on are the components. And it's the components that really make the difference. So the component layer is very important. So if you can read French, you'll note that this says, this is not a pipe. And it says that because it's merely a picture of a pipe. It represents a pipe. I can't really smoke it, I can't hold it, I can't do all those other things. And a representation is actually a critical aspect of the web, because the HTTP protocol is the only one that actually is based on the idea that you don't really send a copy of what's on the server, you send a representation of it. I don't send a MySQL data table to you. I send an HTML representation of the data in the MySQL table, or a PNG representation, a pie chart of what's in the MySQL table. Representation is very, very important. And it's important to build a system that treats representation as a layer, because we have so many more devices today. This device explosion means that I've got a representation challenge. And representation happens in the connector, or just next to the connector. It's actually what exists between connectors and components. So HTTP has these things built in. There are these things called accept headers and content types, where clients and servers can actually negotiate for what they want. Different clients are going to want different kinds of representations. What's on a tablet or a smartphone or a browser could be very, very different. So it's important to design a system that's going to be able to switch representational rules without having to affect the component infrastructure. Is an important separation of concern. Caching layer is also very, very important as well. HTTP, by its very nature, is very slow and unreliable. Caching is what makes it work. So creating caches is very, very important. And caching happens everywhere. It's kind of an anarchic system. There are two basic things. There's caching saying, keep this for 10 minutes. There's another caching model that says, keep this until it's changed. It's called the validation model. So the expires model has a couple of headers, and the validation model has a different set, e-tags, if match. There's some very, very smart technology there that I won't spend too much time on today. But it's really important to support caching for both client and server. If you build a client application, it's important to be a good citizen and use your caching services properly. And that's going to make a huge difference for your applications. There are lots of tools that can do caching. Squid is probably the most popular open source one. Memcached does a lot of internal things, so you can just do internal caching. It doesn't speak HTTP cache. And there are also some very cool proxies that do that. So we've talked about this component architecture. We've talked about the connector architecture, the representation piece, the caching piece. And security is also important as well. I'm not going to go into this in high detail, but security happens at the very edges. There are lots of things built into the web to make it possible to authenticate and authorize, even at proxy levels. And it's important to keep the authentication details out of your component infrastructure. You don't want developers writing authentication code. You want to use a proxy service. You want to use a secure firewall product for that. And it's important that you treat that authentication just like you would representations. Some people may want to use OAuth. Others are going to want to use certificates. Somebody else is going to want to use forms authentication. There are lots of possibilities. Don't keep rewriting component infrastructure when you could have somebody doing that for you. Authentication is different than authorization. Authentication is who am I, and authorization is what can I do today. Authorization, try to get that done as early as possible in the firewall, but sometimes that's going to be down at the component level. But the important thing is to make sure that you do it as soon as you can so you can say no quickly and easily. There are lots and lots of security and routing proxies available. Of course, I will tell you that Layer 7s is fantastic. They've been around a long time. But it's not necessarily important that you like one or the other, but it's very important that you use it and you have a lot of confidence in it. These security and routing proxies are also very important because it lets your security team focus on best of breed. You don't get sort of stuck in a system where you sort of have an all or nothing view. So from the implementation side, components and connectors are separate. Keep them that way. Use a representation layer to do the translation between the two and make sure that that's a full separation of concern so you can support multiple representations. Make sure that you're taking advantage of public caching, not just internal memory caching, but public caching to make your system reliable and responsive. And make sure that you take advantage of a security layer and keep that outside your internal component code. Those are all very, very important. Okay. Let's take a second here, and I've got one more section, and then I want to see if I can't leave a few more minutes at the end. I want to talk a little bit about the interaction model. So now I want to focus directly on devs, the people who are going to use your API. It's important that they love things too, right? So what I want to talk about is this interaction model as an implementation strategy. When you decide what you're going to do and how you're going to finally build this out, there's all sorts of decisions. I've talked about all these other implementation details, but it's important to adopt a developer's point of view on some of this. So how do we make good choices? How do we make choices that make this a lovable API, a usable API, and what are the basis for those choices? So do I use a particular model such as the SOAP or the CRUD interface or the hypermedia REST style? Should I be using XML? Should I be using JSON? Should I use HTML? Should I just follow the crowd? Is there actually a reason that I should pick one or the other? Which caching should I use? What kind of security? These are all choices you have to make really, really early on. And it's important to make them consistently. Even how I report error. These are all things that you've got to decide. And like I had mentioned early on, what we say is focus on the interaction, not the technology. Great APIs are based on interactions between parties. They start with a user perspective, and in this case, that user for your API is your developer. Focus on how this API is going to be used, not what it's exposing. Don't focus on users or warehouses or products or invoices. Focus on buying a product, creating a user. So all these things that we know about user experience design, about how that feeds into engineering and that feeds into the product and it gets back into the user experience design, works exactly the same way if we start thinking about it in terms of developer experience. So this is just another cycle. This is another evaluation execution cycle, just like I talked about in the beginning. And it's really important to think about it that way. So 3 questions. Who's using it? What will be created with it, and how will it actually behave at runtime? So these are the kinds of things that we think about, and think about them from that developer interaction. So I've got my API, I've got the applications that are built with it, and I've got the end users that are going to end up using what the developer built. So you kind of have this distance between the actual API and the end user. There are lots of things that go into this. So we mentioned this. Focus on activities, not objects. So there are certain things I want to do, say if I've got a book product, right? So I need to make sure that I help the developer solve a problem. The developer doesn't want to know what the database is or where it's stored or the details of how a particular database stores interactions. That may not even be a database that that developer uses. So it's also important to make sure, even though somebody may think, hey, this is going to be a really good idea, it may not be the interface you want to provide. It may not be strategically smart for you to expose certain parts of your system to the outside world, so it's much better for you to design an interaction model that strengthens your best product space and also helps that developer out. Don't just blindly expose your object graph to the outside world. So focus on the behavior of the interface. Build a model of the tasks. What are the tasks that people need to do? And there are lots of tools that you can use to do this. You might like actors, user scenarios, personas. There are lots of ways you can think about how people do this. Identify the data needed to complete the task. Notice I didn't say identify the data you have stored in your database. Figure out for this particular task, what is the data I need to share? And share only that. Don't share a bunch of other data. Don't make a bunch of other decisions at this time. Don't expose things you don't need to expose. And then map out the details for each interaction. For get books, I'm going to give them this bit of information, and if I want to purchase a book, it's going to send me certain other information back and forth. So you work out this actual interaction experience, not some sort of complicated, build this data service and expose it as a data service sort of pattern. So some additional tips. Don't forget error handling. It's not enough to just say 404 or just say no. Is this a fixable error? Can the user do this again? Can the developer write some kind of interface that can tell what went wrong and fix it for that user so the user doesn't even know it? Is it repeatable? Can I post this again, or can I send this again, or is that going to cause problems? Am I going to double bill? Make sure that it's hard to make that kind of mistake. Make sure they know what's safe and what's unsafe. Make sure you use the protocol properly and you document things properly so people don't mistakenly think they're reading something when they're really sending a delete message. So the errors are very important. Also, at this interaction level, keep it relatively abstract. Don't get tied up in what formats or what libraries or what frameworks you're going to use. Focus on describing that interaction itself, and then let the technology solve the problems for you. It doesn't matter if you're using HTTP or WebSockets, if you're using SOAP or CRUD or hypermedia, you still need the same interactions. So take advantage of that. Maintain that domain, that developer experience perspective at all times, and that's really going to win out. And it's very important because what's going to happen somewhere down the road is somebody will say, hey, this works great as a website. Let's do it as a mobile and use WebSockets. If you've tied yourself directly to a particular technology and that's how you describe your model, it's going to be hard to switch. If you keep that description separate, it's going to be much easier over time. Okay, so let's talk about this a little bit. So focus on interactions and not technologies. Maintain that developer perspective. Work on that tasks to data to models. Don't start with data. Start with tasks. And then be sure to keep things relatively abstract. And in the end, that's going to give you lots and lots of opportunity, because if you do it at this level, it's much easier for other members of the team, whether they're in the product side or the marketing side or the business side itself, to participate in this. They don't have to know the details of Apache or the details of C# or Java or PHP or any of that. They just know the interactions and what's important. Let's see. If we've got any other questions here? No? Okay, well, let me go ahead and just do a quick summary, and that will give us some open time. If you've got any questions, make sure you start typing them in, because we'll have a chance to interact here in a little bit. So I talked about this usable and scalable and evolvable. Think about your API as your interface. Make sure that you plan for scaling, and make sure that you favor extending over versioning whenever possible so that you don't have to maintain multiple timelines and people can continue to use your app well into the future. We didn't really talk about styles. I skipped over that. Sorry about that. We talked about implementing a solid foundation through this notion of separation of concerns. Components versus connectors, a representation layer, a caching layer, a security layer. A clean separation of all these is going to make it much easier for you to evolve and change and react to things. And then the notion, what we just talked about, which is interactions, focused, developer perspective, based on task, keeping it abstract. And that's going to give you a lot of opportunity for change over time as well, because you're really going to be taking that sort of happy path of focusing on the way things interact, not the data storage system or the technology itself that you're using for those things. So really, those are the things I wanted to talk about from the business perspective, from the architectural perspective, from the implementation point of view, and from that developer point of view. So hopefully that's given you some ideas. I see we're maybe getting some more questions in here. Let me see if I can focus on those. If you haven't entered them in, go ahead and enter them now. Excuse me while I just take a slight drink here of my water. Okay, what are the standard practices followed in the industry to customize the API between different mobile devices, iPads, phone, and tablets? It's an excellent question. So there are a couple of things going on right now. First of all, the good news is every device has a pretty clear identifier in HTTP headers. So I know if I'm talking to an iOS device, an Android device. It's also fairly easy to get information like the layout, the dimensions of my screen, and so on and so forth. So a lot of what you're going to get in your connector layer and in your representation layer is information about the specific thing that's talking to you at this moment. So if you want to, you can actually change your representation based on this metadata for every single call. Now, that's one possibility. Another possibility is there's a movement that's gone on for the last year or so called responsive design. The idea is that you try to build client applications that can sense and real-time on the client side how to render this response, how to render what I just got back to fit this particular device. So we have cases where there's some HTML5 libraries that actually modify on the client the representation that gets sent down based on the size of the device. That's kind of nice because you take some of that decision off of the server and put it on the device. So in some ways that might scale better. It scales better for the server, but not the device, because now the device itself has to figure that out, and a lot of that chugging and churning, especially on small handheld devices, takes up battery space. So we have these two angles, using the metadata sent by the device on the server and deciding in the representation layer exactly how to craft a custom response. And we have this responsive design pattern on the client, which means sending a standard response and letting the client sort of sort things out. So those are the two basic patterns. Let me make sure I'm not missing these along the way. Okay, very good. Here's another one. How do you deal with the chicken-egg problem when creating a brand new API with no existing users? How do you validate and iterate and avoid releasing a poor API? Oh, this is a very good question, David. So I would tell you the best way to do this is through hack events. It's through actual product testing, just like you would test any other physical product on the market. And if this is an internal system, you can create a hack event inside your organization, same way you would anything else. Hey, we got a new API. If you guys would come in and play with it, we'd love to see what your feedback is and how you're going to get that. You know, that's going to be your community that aims at this API. Get some volunteers in and do that, and really pay attention to what they tell you, because you'll be a winner. If this is something on the outside world, do the same thing. Get a skunkworks project, get a POC together, and do something that is not some grand scale, but a nice small scale. One of the things we tell people is lots of small bets, not one big bet. So you can definitely do this and treat it just like you would any other product. Now you're participating in that execution evaluation cycle at the product release level. So do that over and over again, and you'll learn really, really early on how to do that. So that's a good question. I'm glad you brought that up. Let's see, we got another one here. We got a little bit of time, I think. People do use composite API call model. API call over REST, over HTTP, from the client server, and the notification from server. I'm not sure I really understand this question here. People use composite call. I'm going to make a guess here, and if this is not right, I apologize. So in some cases, what happens is we have a very chatty API. So the client has to compose several requests in order to solve a problem. If we want to do something, I get a user account, and then I get some of their user metadata, then I go find all of the products they're interested in, then I find that one product, and then I go find the latest price. I've got to like do 6 or 7 things. It's really important over HTTP to design a chunky, not chatty kind of interaction model, and that's why we say focus on interactions and tasks. Find out what it is that people want to do and what the data that you need to supply just for that one thing. It doesn't mean that you don't allow people to create very interesting clients using lots of other features, but if you focus on those key tasks, you can shorten the distance from start to finish. Another way you can learn this after the fact is watching your logs, where you talk about big data. Why is it that everybody makes these 3 or 4 calls in a row every time? Hey, can we make that one call and improve both the developer and the user experience? Let's see, we've got another one here. Oh, how to best document an API. I skipped documentation on this one because it's a pretty big topic. There are some documentation generator tools out there that sort of mimic the whistle pattern, the waddle pattern. There's Swagger, there's Docs.io. The important thing is to make sure that the docs are readable and very, very timely. We'll do something else on docs. I'm sorry I can't really cover a lot of that at that time, but we'll definitely talk some more about that. Let me see if I can get one more in here. We're running up against the timeline. Let's see. When our API needs to return error codes, is it okay to return HTTP? This is a great question. Let me give you an answer on this one. By the way, we do have an Academy vid on this. Remember that HTTP is a protocol code. It isn't actually application specific. So what you can do is you return, HTTP 400, but in that return a body message that's specific for your application that has an error message, maybe some corrective text. If the person is actually an admin or a logged in user, you might even give them a link to some extra internal details. Combine it with both protocol level and also application specific information. There's a good video on that, check that one out. Okay, how are we doing on time here? I think we're probably out for the day. Let me just remind everyone that we're going to be giving away a copy of the book. It's going to be random from the names of people who had signed up, so you'll get an email on it. Also, we'll make these slides available, and I just want to mention also that my buddy Alex is also doing an event next week online, and make sure you tune in and get some information on that. I think it's going to be the ROI event, ROI Hackathons. So there's lots and lots of cool stuff coming up. And join us on Twitter, Facebook, all the other places, and I hope to get to see you guys again really soon. Thank you very, very much for tuning in.